What is a glycosidic linkage?
A glycosidic linkage is the chemical bond that bonds a carbohydrate to another carbohydrate molecule, or to another species. Glycosidic linkages are what hold together all of the individual glucose monomers that make up glycogen or starch. The figure below shows a glycosidic linkage. The enzymes that catalyze the breakage glycosidic linkages are called glycoside hydrolases. These are necessary to allow for glucose to be released from storage. The enzymes responsible for forming the linkages are called glycosyltransferases.
What is absorption?
Attachment of one substance to another, see absorption and adsorption.
How much error is associated with electronic structure theory calculations?
There can be a pretty large amount of error associated with these calculations. And the main goal is to keep the errors as consistent as possible and to obtain properties via differences in calculations. For example, the energy of the metal-carbon bond in Cr(Co)6 would be calculated by comparing the energy calculated for Cr(Co)6 to that calculated for Cr(Co)5 and Co separated from one another at infinite distance.
If baking soda and baking powder are different, how can I substitute one for another?
Since baking powder is diluted baking soda with acid. If your recipe calls for powder but you only have soda, you'll need to use less, but add an acid. Generally the ratio is 3 parts baking powder equals 1 part baking soda with 2 parts cream of tartar, or another acid substitute.
Why should a chemist add acid to water and not the other way around?
This is an issue of safety. When an acid mixes with water, it will react very quickly. This reaction can release a large amount of heat and can cause the solution to bubble or splash. It's important to pour an acid into water, since acidic solutions are almost always more dense than pure water, meaning that the acidic solution will sink down into the water as it reacts. If you were to add water to a more dense acidic solution, the water would react at the surface of the solution, and there is a much greater chance it could bubble or splash up at you.
What is an empirical formula?
The relative ratios of elements in a substance.
What is paramagnetic?
A molecule with no net spin. A material that is only attracted in the presence of an external magnetic field.
What is a base?
A compound that accepts hydrogen ions, Brønsted-Lowry acid. Has a pair of available electrons, Lewis, or releases hydroxide ions in solution, Arrhenius.
What is a detection limit?
The detection limit for a measurement is the lowest amount of signal that can be distinguished from the background level of noise. The detection limit is commonly reported with a confidence level describing the percent confidence with which the measured signal at the detection limit can be stated to be above the noise intrinsic to the experiment.
How can I grow a large crystal?
Chemistry principles encountered in this experiment, crystallization solubility materials you'll need. Hot water, from the tap is fine, about 2.5 tablespoons of alum. This is typically found with the spices in the grocery store, it is an ingredient used to make pickles crisp. Its chemical formula is Kal, so for 212H2O, nylon fishing line or thread, about 15 centimeters. A pencil or ruler, 2 jars, spoon, coffee filter or paper towels. The procedure: pour 1/2 cup of hot water into a jar. Add a little bit of alum to the water and stir it in. Try to do this before the water cools down too much. As you'll recall, we can expect the alum to be more soluble at higher temperatures. We want to create a saturated solution of alum, but we also want to make sure that all of it dissolves. Continue adding alum until it will not dissolve anymore. And then you can add a little bit more hot water to get the last bit of alum to dissolve. Cover the jar with a coffee filter or paper towel and let it sit overnight. The next day, pour the liquid into a second jar. There should be small crystals left in the bottom of the first jar. The process of pouring the liquid off of the top of the solid crystals is known as decanting. The crystals left behind will serve as the seed crystals to grow a larger crystal of alum. Pick out the largest crystal, or one with a nice shape that you like. Tie the fishing line or thread around the crystal. And tie the other end of the line to a pencil, ruler, or other long flat object. Adjust the length of the string such that you can use the pencil or ruler to dangle your crystal from the top of the second jar. The one that now contains the liquid, into the liquid without it touching the bottom. Once your crystal is hanging into the solution, all you have to do is sit back and wait for it to grow. This might take several days. If you notice small crystals growing on the sides or bottom of the jar, it would be a good idea to transfer the solution and your single growing crystal into another jar to prevent the alum in solution from crystallizing into several different crystals. This will ensure that you get a nice big crystal. You can feel free to transfer jars as many times as necessary to continue growing your large crystal. History of Chemistry Timeline Year Event 1859 to 1860 The early foundations of spectroscopy are established by Gustav Kirchhoff and Robert Bunsen. 1864 The Law of Octaves. An important step leading to development of the modern periodic table, is first proposed. 1865 The number of molecules in 1 mole of a substance is first determined. 1869 Mendeleev publishes the first version of the modern periodic table, containing 66 elements, and leaving space for yet to be discovered elements. 1869 DNA is first discovered. 1874 The second law of thermodynamics is proposed by Lord Kelvin. 1874 Electric current is proposed to be caused by the motion of electrons. 1876 The concept of free energy is introduced, by Josiah Willard Gibbs to explain chemical equilibria. 1877 Ludwig Boltzmann provides a definition of entropy, along with statistical derivations of several other physical concepts. 1884 Le Chatelier's principle is first introduced, explaining changes in chemical equilibria upon the introduction of changes in a chemical system. 1887 The photoelectric effect is first discovered. 1888 Radio waves are discovered by Heinrich Hertz. 1893 Alfred Werner establishes that some cobalt complexes involve a central cobalt atom bonded to an octahedral arrangement of 6 ligands, laying the groundwork for the field of coordination chemistry. 1894 Noble gases are first discovered. 1895 X-ray radiation is discovered. 1897 The electron is discovered. 1900 Planck's constant is first introduced by Max Planck. 1900 Ernest Rutherford establishes that radioactivity is caused by the decay of atoms. 1901 The Nobel Prizes are awarded for the first time.
How many nuclear power plants are there in the United States?
There are currently 65 nuclear power plants in the U.S. and a total of 104 nuclear reactors. This is because 36 plants have more than one reactor.
What is a nucleobase?
Nitrogen-containing molecules that form nucleic acids, adenine, cytosine, guanine, thymine. Uracil are the major nucleobases, form base pairs via hydrogen bonding between the two helical strands of DNA.
What does that mean?
Superimposable means one object can be placed over another, or less technically, that they're identical. So enantiomers are not identical, but they are mirror images. Take a look at your hands, they are enantiomers. If you put one hand up to a mirror, it looks like your other hand, so they are mirror images. But if you try to put one hand on top of your other, no, not palm to palm. That's cheating. You see, they're not identical, therefore non-superimposable.
What is freezer burn?
Freezer burn occurs when frozen food undergoes dehydration due to improper packaging. The humidity level in a freezer is usually quite low, so if food is not stored in airtight packaging, water in the food can be drawn out into the freezer atmosphere by sublimation. Also, because the food is exposed to air, oxidation can occur. Though at the lower temperatures in a freezer, these reactions are quite slow. Thankfully, although freezer burn looks nasty, it's not a food safety concern, it just causes discoloration.
What is a physical change?
A change in the macroscopic properties of a substance without a change in its chemical composition.
Is starch different than cellulose?
Starch is also a polysaccharide, like cellulose, but it is much less crystalline. The major component of starch is amylopectin, which is a highly branched polymer, while cellulose is strictly linear. These branches prevent amylopectin from crystallizing as well as cellulose. Starch is an excellent source of energy, or stored sugar, for plants and animals for these reasons. Because it is less crystalline than cellulose, it is more soluble than cellulose. And the branched structure also means there are more end groups at which enzymes can start chewing the polymer apart.
How do hydrogen-powered cars get their energy?
Hydrogen-powered cars are based on fuel cells that store hydrogen, or H2 gas, inside a material called a polymer exchange membrane. The fuel cell contains two electrodes, an anode, negative side, and a cathode, positive side. At the anode, the H2 molecules are split into protons and electrons. The protons pass through a polymer exchange membrane, while the electrons are unable to pass through this membrane and thus have to flow in a different direction. This creates a current of electricity by which the car is powered.
When I get an MRI, what is the machine actually measuring?
An MRI is basically just performing an NMR measurement on the hydrogen atoms in your body. Similar to an NMR instrument, an MRI instrument uses a large magnet and a radio frequency pulse to generate a rotating net magnetization in the hydrogen atoms in your body. The resulting magnetization generates an electric current in a receiver in the MRI instrument that can be processed to generate an image of what's going on inside your body.
Why does salt melt ice?
Adding salt to ice lowers the melting point of water. See freezing point depression in macroscopic properties. So when you pour salt on the ice on your driveway, the melting point of the salt-water mixture you made by adding the salt may be lowered sufficiently such that it is below the outside temperature, which means the solid ice will start to melt.
What are the different phases of matter?
There are three phases, or states, of matter that you come across every day: solids, liquids, and gases. There is a fourth phase of matter, plasma, which is only naturally found in stars and elsewhere in outer space. The distinctions between the first three phases are usually made using bulk properties. Solids have a defined shape and volume, while liquids easily change their shape but not their volume. Gases have neither a defined shape nor volume.
What are the 5 environmental spheres?
In the past, environmental science focused on the health of 4 areas, or spheres, of our world. These are the hydrosphere, dealing with water; the atmosphere, dealing with the air; the geosphere, dealing with the earth; and the biosphere, dealing with living organisms. Environmental scientists have recently been increasingly recognizing a 5th sphere, the anthrosphere, which deals with the ways that humans modify the overall environment by carrying out their daily activities.
What is a fuel cell?
Device that converts chemical energy to electrical energy.
Which energy sources produce the most CO2?
By far, it's the fossil fuels, oil, gas, and coal. It's the CO2 from all those combustion reactions that makes up about 96.5% of all the carbon dioxide emissions.
What molecules have chemists detected in interstellar space?
A recent count puts the number of distinct molecules detected in interstellar space at around 150. The list includes small diatomic molecules that are common on Earth, e.g., Co, N2, O2, high-energy diatomic radicals that have exceedingly short lifetimes on Earth, e.g., HO, HC, and all the way up to organic compounds like acetone, ethylene glycol, and benzene.
What is electronic structure theory?
Electronic structure theory is an area of theoretical chemistry that is focused on calculating the arrangement and energies associated with configurations of electrons in molecules. This can include predicting the structure of a molecule, the most probable arrangement of its electrons, its reactivity, and different excited states of the molecule. For reasons we won't go into, this is not an easy task. And the electronic structure of molecules cannot be solved exactly, even with very powerful computers. Most theoretical chemists working in this area develop approximations for calculating the true electronic structure of molecules and on testing these approximations against available experimental data to continue to improve existing methods. The electronic properties of molecules play a vital role in determining their stability and reactivity. So despite being challenging, it's a problem well worth trying to solve.
Why did Lord Alexander R. Todd, United Kingdom, win the Nobel Prize for Chemistry?
For his work on nucleotides and nucleotide coenzymes. Todd laid the foundation for future research in biochemistry, genetics, and biology surrounding the structures and roles of nucleotides in living organisms. He established the chemical structures of nucleotides and established the, extremely important, role of phosphorylation in biochemical processes.
What is voltage?
The difference in electrical potential between two locations.
What is a van der Waals force?
Intermolecular forces between molecules resulting from the interactions of dipoles or induced dipoles.
What is resonance?
A way of describing the delocalization of electron density in a molecule.
What is meteoric iron?
Meteoric iron is just what the name sounds like, it's iron that comes from meteors. For early civilizations, meteoric iron was one of the few available sources of relatively pure iron. That is, prior to when the extraction of iron from ore was discovered. Meteors containing meteoric iron are composed of mostly nickel-iron alloys. Iron meteorites often have a distinct appearance, and they are typically much easier to recognize than other types of meteorites. For this reason, they are discovered more often than other types of meteorites. Iron meteorites actually account for all of the largest meteorites that have been discovered.
Can eating carrots help your eyesight?
It does seem likely that carrots help your eyesight, so it's not a myth. Carrots, and other colorful vegetables, tend to have a lot of vitamin A. And vitamin A helps the retina to stay healthy and working well. This is because it helps to generate rhodopsin, which is a light-sensing molecule located in the retina. Developing a deficiency of vitamin A can actually lead to night blindness.
What is a carbanion?
An anion in which a carbon atom bears a significant fraction of the negative charge.
What is matter?
Any substance that has mass.
What is mass spectrometry?
Mass spectrometry is a method of chemical analysis that involves determining the molecular mass of charged particles by measuring the mass-to-charge ratio of an ionized molecule or molecular fragment. There are several ways of performing mass spectrometry, but the general procedure involves making the sample into a vapor, ionizing the sample, and then detecting the ions that form in a way that separates them according to their mass-to-charge ratio. After being ionized, the molecules in the sample will often fragment into smaller ions, and these too are detected according to their mass-to-charge ratio. This technique can be useful for carrying out an accurate determination of the mass of a molecule, as well as for obtaining structural information about molecules via their fragmentation patterns. It also allows the elemental composition of a sample to be determined.
What are chromosomes?
Chromosomes are a bundle of DNA and proteins packaged together. They are how your DNA is stored in your cells when it isn't being read by any enzymes. Each chromosome contains a large number of genes. Humans each have 46 chromosomes, all of which are present in each cell in the body. Chromosomes need to be unpacked by enzymes before their DNA can be read by RNA polymerase or other enzymes.
So is there a tannin taste bud?
No one knows yet.
Why do metals make for such effective active sites in enzyme catalysis?
Metals are crucial components in enzymatic catalysis for largely the same reasons that organometallic complexes make good catalysts. These include the fact that many metal centers can complex to a variety of substrates, undergo facile changes in oxidation state, and provide good electron donors or acceptors. These characteristics can, and often do, work together to accomplish some remarkable chemical feats.
Is sodium lauryl sulfate toxic?
You're probably asking this because you've seen this chemical listed on your shampoo or toothpaste, and at the levels in those products. No, it is not toxic. This molecule is a surfactant, very similar to many soaps. And like most soaps, if you get them in your eyes, it hurts. The chemical is an irritant, but it does not cause cancer, like you might have heard.
What is the reaction order?
The number of chemical species simultaneously involved in a chemical reaction.
What is a spectrum?
A plot of the absorption intensity of light by a sample as a function of wavelength.
Is our Sun unique?
Aside from the fact that we're spinning around it, not really. It's a yellow dwarf star of average size, 6.960 x 108 m radius, 1.989 x 1030 kilograms, and surface temperature, 5500 to 6000 K.
What is an independent variable?
A variable that is set to a specific, known value in an experiment.
What fifth element did Aristotle add?
Although Empedocles is understood to have been the first to propose the four basic elements, Aristotle is sometimes given this credit. Aristotle did propose a fifth basic element though, which he called ether. Ether was a divine material that Aristotle said made up the stars and other planets in the sky.
How can radioactivity be measured?
Radioactivity is measured by detecting the products of radioactive decay processes. The most well-known instrument used for this purpose is the Geiger counter. A Geiger counter is sensitive to the products of nuclear decay, including alpha and beta particles and gamma rays. The units used to quantify radiation are the Curie or the becquerel, which describe the number of nuclear decays a substance undergoes per unit of time. In many cases, it may not be necessary to directly detect the radiation being given off at this instant, but rather to just determine the isotopic ratio of an element present in a sample. This can be done using techniques borrowed from analytical chemistry, such as mass spectrometry. Information on the isotopic ratio present, along with knowledge of the half-life of the isotope in question, can be related to the age of the sample being studied.
What is the Krebs cycle?
The Krebs cycle, also known as the citric acid cycle or the tricarboxylic acid cycle, is a biochemical process through which organisms can generate energy, in the form of ATP, or adenosine triphosphate, by oxidizing acetate that comes from other biomolecules, sugars, fats, and proteins. Since it uses oxygen, it is called an aerobic process. The Krebs cycle also generates other molecules, such as NADH, nicotinamide adenine dinucleotide, that are used in other biochemical processes. The names citric acid cycle and tricarboxylic acid cycle come from the fact that citric acid is used up and then regenerated in the reactions in the cycle. The name Krebs cycle is named after Hans Adolf Krebs, who was one of its discoverers.
What is a cation?
A positively charged ion.
What is an actactic polymer?
A polymer in which the chiral centers are arranged randomly along the chain.
What about cis and trans fats?
The carbon-carbon double bonds along the hydrocarbon chain. of fatty acids can be either the cis or trans isomers. Naturally occurring unsaturated fats have more cis fats, while man-made fats, like margarine, have a higher level of trans fats. Trans unsaturated fats turn out to be particularly bad for humans as they increase cholesterol, leading to heart disease.
What does hydrophilic mean?
A molecule that interacts favorably with or is attracted to water, typically via hydrogen bonding or other dipolar interactions.
What is the difference between heterogeneous catalysis and homogeneous catalysis?
Homogeneous catalysis takes place when the catalyst and the other reactants are all dissolved in the same solution. Heterogeneous catalysis typically involves the use of a catalyst that is insoluble, or perhaps only weakly soluble, in the solution in which the reaction takes place. Thus, in heterogeneous catalysis, the catalyst and solution may form a suspension, or the catalyst may simply be a solid that is placed in the solution.
What is ductile?
Pliable, not brittle, a metal that can be drawn into a thin wire.
What is nuclear fusion?
Nuclear fusion is the process by which two nuclei combine to form a single, heavier nucleus. Energy is usually released when two lightweight nuclei fuse. Though for heavier nuclei, fusion generally requires an input of energy. Nuclear fusion can be used in bombs to cause a massive and rapid release of energy. Fusion is also responsible for the fact that stars burn bright and give off light and heat.
What is a Kelvin?
Standard temperature scale in which the triple point of water is defined at 273.16 Kelvin.
Why is fugu toxic?
Fugu fish is toxic because of a molecule called tetrodotoxin. This molecule binds to the sodium ion channels in nerve cells, shutting down all communication in your nervous system. The toxin is not affected by cooking, so chefs that prepare this dangerous fish have to be highly trained to avoid serving parts that contain tetrodotoxin. The liver, ovaries, and skin can have very high levels of this poison.
What is the biggest laser in the world?
The largest laser in the world is located at the Lawrence Livermore National Laboratory in Livermore, California. This laser is so large that it covers the size of 3 football fields. The scientists who use this giant laser for their research are hoping to show that a nuclear fusion reaction, see nuclear chemistry, can be controlled and used as a source of energy. If that's possible, it could revolutionize the way power plants make energy.
What is volatile?
A substance that easily evaporates at normal temperatures and pressures.
How do chemists purify compounds?
A few of the most commonly used purification methods are chromatography. See following question, recrystallization or extraction methods. These methods typically exploit a difference in how a property, like polarity, for example, of one chemical species causes it to interact differently with the surrounding material than the others from which it is being separated.
How do bees make honey?
The first step is searching out a flower to pick up some nectar. Nectar is a mixture of sugar and water. Specifically, the sugar in nectar used to make honey is sucrose, a disaccharide. See biochemistry. A honeybee produces enzymes in its body that can break down the sucrose into monosaccharides, fructose, and glucose as well as gluconic acid. These sugars are the primary constituents of honey. Most of the water evaporates, which is what makes honey so viscous and sticky.
What is a chirality?
A geometric property of a molecule whose mirror image is non-superimposable with the original molecule.
What is the decay rate?
Rate at which a nucleus emits a particle.
Why did Arturi Ilmari Virtanen, Finland, win the Nobel Prize for Chemistry?
For his research and inventions in agricultural and nutrition chemistry. Especially for his fodder preservation method. Virtanen was quite an interesting chemist, and he was also a farmer. His fodder preservation method made use of hydrochloric and sulfuric Acids to slow the processes that normally cause fodder to ferment. He also made several other achievements in the area of nutrition/agricultural chemistry, helping to better provide nutrition to animals raised on farms.
How do the atomic radii of atoms change across the table?
The atomic radii of atoms generally decrease going from left to right across a period, and increase going top to bottom down a group. See graphic on next page. The increase in atomic radius going down a group is fairly straightforward to understand. Additional shells of electrons are added and they must surround the inner shells, resulting in an increased atomic radius. Though the number of protons in the nucleus increases going down a group, the inner shells of electrons serve to shield the valence shell from the attractive force of the nucleus, resulting in an overall increase in atomic radius. Moving to the right across a period, the number of protons increases, increasing the attractive force on electrons in the valence shell. Within a period, additional electrons go into the same valence shell, and an increasing attractive pull from the nucleus results in a more contracted valence shell, resulting in a smaller atomic radius. The situation is complicated by the rightmost group, known as the noble gases. But the atomic radius of these elements is typically not important as they are rarely involved in chemical bonds to other atoms.
What metal is at work in alcohol dehydrogenase in your liver?
The active site of alcohol dehydrogenase contains a zinc center that is responsible for catalyzing the reaction of ethanol to acetaldehyde.
How can light be used to initiate a chemical reaction?
When light strikes a molecule, it has the potential to excite an electron to a higher energy level. When this happens, the molecule becomes less stable and more reactive. This can even cause the molecule to fragment, generating a more reactive species or catalyst, which can then go on to react with another molecule.
How can I make hot ice, sodium acetate?
Chemistry principles encountered in this experiment. Chemical reactions, solubility, crystallization and recrystallization, colligative properties. Materials you'll need: pan with cover, microwave or stovetop, vinegar, 1 liter, baking soda, 4 tablespoons, dish. The procedure: pour the vinegar into a pan, and very slowly, a little bit at a time, add the baking soda. As you may already know, this reaction will produce large amounts of bubbles, carbon dioxide gas, so you'll need to add this very slowly. This reaction will produce a solution of sodium acetate in water. Sodium acetate is produced according to the chemical equation Na plus HCO3 plus CH3COOH CH3 Na plus H2O and CO2. Bring the solution to a boil. Allow the solution to continue to boil until a skin or film begins to form on the surface of the solution. This will require heating for a significant amount of time, perhaps up to an hour, until a large fraction of the water from the vinegar has evaporated. Our goal here is to form a very concentrated hot solution of sodium acetate. You'll recall from our discussion of colligative properties that the solubility of a solute is higher at higher temperatures. As we reduce the volume of the water, the sodium acetate will not evaporate, and we will be left with a concentrated solution at high temperature. When you notice a film start to form on the surface, remove the pan from the heat, and cover it to prevent further evaporation. Place it on the countertop or in the refrigerator to cool. If you see any crystals begin to form, add a small amount of additional vinegar, or if you are out of vinegar, use water and stir the solution so that they dissolve. You now have a supercooled solution of sodium acetate that can crystallize out of solution readily if a crystallization nucleus is present. You can now slowly pour the first few drops of the cooled solution onto a dish, and it should begin to crystallize rapidly. If it doesn't, try dragging a fork or knife along the dish to make a tiny scratch. Or give the liquid a moment to evaporate a little so that the sodium acetate begins to crystallize before you begin to pour. As you continue to pour, the liquid should continue to crystallize as it contacts the crystals already formed on the dish. This is similar in spirit to how purification takes place during a recrystallization. See the modern chemical lab. If you feel the crystals, they will be warm to the touch. Since the crystallization is an exothermic process, it gives off heat. This is why it's called hot ice. But now you know it isn't really ice, it's sodium acetate, and you know how to make it.
What is fusion?
The joining of two, or more, atoms.
What is a kinase?
Kinases are a class of enzyme that is responsible for transferring phosphate groups, see image below, from donor molecules, such as ATP, to substrates during a reaction called phosphorylation. These are typically named for their substrate, for example, a tyrosine kinase catalyzes the transfer of a phosphate group to a tyrosine residue of a protein. Kinases are part of a larger group of enzymes called phosphotransferases, all of which carry out chemistry involving phosphate groups, shown below.
What is a dielectric constant?
The dielectric constant of a material characterizes the extent to which it insulates against the flow of charge or against the effects of an electric field. Materials with a high dielectric constant screen the effects of charges within the material, while materials with a low dielectric constant allow the effects of a charge to be felt more strongly. In solutions containing ions, the dielectric constant of the solution will determine the extent to which the other molecules in the solution feel the effects of the charges present. The lowest possible dielectric constant exists in a vacuum in which there is no material present to screen the charge of a field.
Why did Walter Norman Hayworth, United Kingdom, win the Nobel Prize for Chemistry?
For his investigations on carbohydrates and vitamin C, and Paul Karrer, Switzerland. For his investigations on carotenoids, flavins, and vitamins A and B2. Hayworth's work on carbohydrates expanded on that done by Fischer, making significant further progress into understanding the structures of various isomers of monosaccharides and disaccharides. Prior to this work, very little was known about vitamins, carotenoids, and flavins. And these men were the first to uncover the chemical composition of these molecules. In addition to his work with sugars, Hayworth also studied the composition of vitamin C. Karrer shared the prize for his work characterizing the chemical compositions of several carotenoids and flavins, as well as vitamin A and vitamin B2. Knowledge of the chemical compositions of these species provided some of the earliest insights into how they are formed and the roles they play as nutrients in the human body. Prior to their work, little was known regarding the chemistry or reactivity of these species, because their composition was not known.
What is the octet rule?
A rule for chemical bonding that says atoms prefer to have 8 electrons in their valence shell.
What is my credit card made of?
Also PVC, but for the material in credit cards, no plasticizer is added. To manufacture a credit card, usually a few thin sheets of PVC are glued together.
What happens when something biodegrades in a landfill?
Biodegradation describes the process by which microorganisms consume a material and convert it to compounds that are found in nature. This process can happen either aerobically, with oxygen involved in the process, or anaerobically, without oxygen involved in the process. A related term is compostable. This specifically indicates that a material will biodegrade/break down when it is placed in a compost pile.
How does mass spectrometry, MS, work?
The purpose of mass spectrometry is to ionize a chemical sample, causing it to fragment, and to characterize the mass of the fragment ions that form to gain chemical information about the sample. The first thing that happens is that the sample molecules need to be ionized. And this is done by removing an electron from the sample to yield a positively charged species. Once ionized, a sample of molecules will typically fragment in a characteristic way. The ions that form, whether they are fragments or the original ionized species, are accelerated and then deflected in a magnetic field. Ions of different masses are deflected by different amounts. And this is how the masses of the different ions are distinguished.
And the temporal lobe?
The temporal lobe is involved in hearing, memory, and language skills.
What were some early models for the atom?
Experiments suggested that atoms were actually made up of smaller particles, which motivated the development of new models involving protons, neutrons, and electrons. One was Thomson's plum pudding model, which described the atom as a positively charged pudding filled with negatively charged electrons. Rutherford later proposed the idea of a positively charged nucleus, but couldn't explain why electrons didn't just fall into it. A Danish physicist named Niels Bohr proposed the idea that electrons travel around a nucleus in specific orbits and advanced the atomic theory to a point very close to where it is today.
Why did Robert Burns Woodward, United States, win the Nobel Prize for Chemistry?
For his outstanding achievements in the art of organic synthesis. Woodward made tremendous research achievements in a broad range of areas in the field of organic synthesis. He established the structures of aureomycin and terramycin, which are antibiotics, and made possible new synthetic work in this area. He also synthesized quinine, which was considered a great challenge and was used to fight malaria, and later synthesized cholesterol and cortisone. The list of synthetic achievements goes on and on. And he truly ranks among the most successful synthetic chemists ever to have graced the field. In addition to these synthetic achievements, Woodward also established the structures of a large number of important compounds.
What is ink made of?
Inks can be very complicated mixtures, but two key ingredients are the pigment used to color the ink and the solvent used to dissolve, or at least suspend, the pigment particles. While modern inks come in every color imaginable for a host of different pen types. Historically, inks fell into one of two major categories. The first is carbon-based inks. Residues from burning wood or oil, like soot, were used as coloring in these inks, which were suspended in the sap of the acacia tree, known today as gum arabic. The other type of ink used historically is called iron gall. The iron was usually added in the form of iron sulfate, Fe2 plus SO4. Gall refers to gallotanic acid that was extracted from growths, or galls, on oak trees. Iron gall ink slowly darkens as the iron ions undergo oxidation from Fe2 plus to Fe3 plus. The acidity of the ink solution can cause damage to the paper it is used on. So preservation of historical documents that were written with iron gall ink is challenging.
What is an amphoteric molecule?
An amphoteric molecule is one that can act as either an acid or a base. Either the Lewis or Bronsted definition of acid/base. Behavior can be used to define a species as amphoteric.
What is a hybrid orbital?
An orbital that is composed of multiple atomic orbitals, e.g., sp3 hybrid orbital.
How many electrons can fit in each orbital?
Each atomic orbital can contain up to 2 electrons. Electrons have a property called spin angular momentum, which can take on two different values of opposite sign. It turns out that electrons residing in the same atomic orbital must have opposite spin angular momenta. This is a consequence of a physical principle known as the Pauli exclusion principle.
Can light move through a vacuum?
Yes. Unlike sound, light is an electromagnetic wave, so no molecules are needed to propagate the wave. But you knew this: the sun's light crosses the vacuum of space to reach Earth each and every day.
How much energy in the United States comes from hydroelectric power sources?
About 10% of the electricity in the United States comes from hydroelectric power sources. The state of Washington leads the United States in hydroelectric energy production, with roughly 87% of the state's electricity coming from hydroelectric power.
What is electrical resistivity?
Electrical resistivity is a measure of how well a material resists the flow of an electric current. A material with a high electrical resistivity is a poor conductor of electricity, while a material with a low electrical resistivity is a good conductor of electricity.
What are the rings around Saturn?
You have probably heard about, and looked at pictures of, the rings around the planet Saturn. On average, these rings are about 20 meters thick and they are made up of 93% ice and about 7% carbon. There is actually a pretty large distribution of particle sizes in these rings, ranging from specks the size of dust to chunks of material 10 meters in length. Actually, the origin of the rings is not completely understood, and they may be due to either a destroyed moon or to leftover material from when Saturn was formed.
What is a chemiluminescence?
Emission of light resulting from a chemical reaction.
What makes metals good conductors?
An electrical current is the movement of electrons. So a conductive material allows the free movement of electrons. Metals are good conductors of electricity because of their electronic structure. There are basically two big groups of orbitals in metals: the valence band and the conduction band. The valence band is the group of orbitals that are normally filled in a metal, while the conduction band is empty. These are called bands because they are made up of sets of closely spaced energy levels. Metals, and other good conductors of electricity, can have very small or no band gaps at all. Semiconductors have small band gaps, and electrons can be promoted from the valence band to the conduction band either by heat or light. Insulators, materials that do not conduct electricity, have large band gaps.
What is a stereochemistry?
Relative arrangement of atoms of a molecule in 3D space, see also stereoisomer, enantiomer, diastereomer.